Hi, my name is Pao Corrales. I'm from Argentina and I have a PhD in atmospheric sciences. I'm now a research software engineer at the Center of Excellence for the 21st Century Weather in Australia, where I support researchers studying what the weather will look like while our planet keeps warming up. I'm passionate about open software, open science, and open education. My first encounter with open software was as an undergrad student learning programming. Soon after, I joined Our Ladies as an organizer, and I helped organize Latin R, the first of many Latin American conferences for the use of R. I quickly learned to value the community surrounding different open source software projects. Openness has also guided my research. My desire to share what I do in case it may be useful to others led me to write my first R package, to publish my research and analysis on GitHub, and to document the software tools I developed during my PhD. Along the way, I built skills in reproducibility, collaboration, and openness, all of which I now bring into my role as a RSC. Finally, I deeply enjoy teaching. I've been teaching programming in different settings for 10 years, and the two constants along all the time has been that my teaching materials are openly available under CC BY licenses, and that I use evidence-based practices to give students the best chance to learn effectively. I also train others to teach programming as a trainer for the carpentries, multiplying the impact of open education. Thinking about climate change and more broadly the impact of human activities is part of my everyday work. As a researcher and RSC in climate and weather, I cannot ignore that our own research practices also have an environmental footprint, especially the energy demand of running big numerical models to simulate the climate and weather. There are already inspiring initiatives addressing this, such as Green Disk, which helps organizations assess their digital sustainability, and Green Algorithms, which provides researchers practical ways to measure the carbon impact of their computations. These tools show what's possible, but also highlight that there's still a long way to go, especially in an area where sustainability is rarely part of the conversation. My project aims to contribute to this growing movement of green computing by promoting these ideas and adapting existing tools for local research contexts. By building on what already exists, I want to connect researchers and RSCs in my region with global efforts and take the next steps towards making climate and weather research more sustainable. The first step in my project will be to start the conversation about green computing in the climate and weather research community. While these discussions are growing globally, they are still uncommon in our field, even though we rely on some of the most computationally intensive numerical models to simulate the weather and climate. This is a gap I want to help close. I will use my teaching and community experience to raise awareness on sustainable practices in climate and weather research. Concretely, I will present the project in key forums, including the Research Software Asia-Australia Conference, the New Zealand RSC Conference, and some of the climate and weather conferences in the region. I will organize a hackathon-style event focused on green computing in climate and weather research. This event will invite participants to explore the impact of our computational work, identify local challenges, and define what tools and resources the community needs. I will publish openly materials and key findings so that others can use them. These activities will bring together researchers and RSCs to discuss what research needs, how we can help to support those needs, and how this can be achieved in a sustainable way. By connecting with the Software Sustainability Institute community and the Community for Environmentally Sustainable Computational Science, I will ensure that those regional discussions contribute to, but also learn from global initiatives on sustainable research software. In particular, there is a natural connection with the UK Met Office, whose models underpin much of the climate and weather research we run in Australia. This fellowship will allow me to build bridges between them. Alongside with communication and outreach, I want to make practical contributions to the tools available for sustainable computing. During the fellowship, I will adapt existing tools like green algorithm for HPC to local research infrastructures used for climate and weather research, use the outcomes from the hackathon and community discussions to identify specific gaps and needs, and develop and prototype new tools in response to these community needs. One potential tool could support decision-making on when to run the code based on existing information about energy generation and demand. These outcomes will help researchers make informed choices about efficiency and environmental impact when running large-scale simulation of the atmosphere and oceans. Through the fellowship, I hope to connect local initiatives in Australia and the region with the global community, contributing both regionally and globally to the sustainable research software movement. Thanks for listening, and in particular thanks to SSIs and fellows for the support I received during the application process.